The essence of math is not to make simple things complicated, but to make complicated things simple. Good day, everyone. I am Sergio, a grade 7 mathematics teacher of Tabaco National High School, and I will be teaching you about the first concept of Math 7, which is on sets. Before anything else, let us define what is a set. When we say a set, this is simply the mathematical model for a collection of different things. A set contains elements or members which can be mathematical objects of any kind, such as numbers, symbols, points in space, lines, other geometrical shapes, variables, or even other sets. In generic term, when we say set, this is simply a group or collection of objects. How do we name a set? In naming a given set, we use capital letters. So it only means to say we are going to use capital letters in naming a specific set. The first term associated with set is the term element. What is an element of a given set? When we say element of a set, it can also be known as the member of a set. When we say element or member of a given set, that is simply the object in that set. Another term associated with sets is cardinality. What is the cardinality of a given set? This is simply the number of elements in the set. There are different kinds of sets, one of which is the unit set. Let us first define what a unit set is. When we say a unit set, this is simply a set having only one element or the cardinality is 1. An example of a unit set is the set of stars in the solar system. Why do you think that it is an example of a unit set? It is because the cardinality of the given set is only 1 because there is only one star in the solar system, which is the sun. Another kind of set is the empty set or the null set. When we say empty or null set, this is simply a set that has no element or the cardinality is 0. An example of an empty set is the set of triangles with 4 sides. Why is it that the given set is an empty set? That is because there is no such thing as a triangle having 4 sides. Another kind of set is the finite set. We can say that a set is finite if and only if it is a set whose cardinality is a whole number. This only means to say that a set is finite if you can count the number of elements in the given set. The next kind of set is the infinite set. When we say infinite set, this is a set whose cardinality is infinity or the number of elements cannot be counted. Those are the different kinds of sets. Let us recall what is the definition of a set. A set is a group or collection of objects. But there is a more specific definition for a set, and that is a set is a well-defined group or collection of distinct objects. What do you think is the meaning of well-defined? How about distinct? When we say well-defined, this means that it is clearly stated or described. How about the other term, distinct? When we say distinct, this means that it is recognizably different in nature from something else of a similar type. Again, when we say set, a set is a well-defined group or collection of distinct objects. Okay, so here are some of the given examples. So here are the different statements where we are going to identify whether the given statement represents a well-defined set or a not well-defined set. For number 1, the group of excellent presidents of the Philippines. So as you can see here, it contains an adjective which is the excellent. And when we say excellent, it is somewhat subjective. We have different standards of excellence when it comes to their performance. So therefore, number 1 is a not well-defined set because it is somewhat subjective. We have different standards of excellence, so therefore, it is not universal. So number 1 is a not well-defined. The next one is the group of four-legged animals. So here, as you can see, think of a given element of the set, and that is, or it can be a cat or a dog. So we all know that cats and even dogs have 4 legs. So therefore, this statement is a well-defined set. Another statement is the group of good basketball players. As you can see here, the adjective here is the term good. And when we say good, we can say that there are different definitions or perspective of being a good basketball player, and therefore this is not well-defined set. Okay, so how about Stephen Curry? If you are going to ask some people, they will say that Stephen Curry is a good basketball player. But if you ask a person who is a basher of Stephen Curry, therefore, he will say that he is not a good basketball player. So therefore, it is again subjective. That is the reason why it is not well defined. Another example is the group of days in a week. So if you're going to analyze the given statement, this is well defined. Why? Because if you're going to get an element from the given set, we can say that Monday is a day in a week. So if you're going to ask any person from any part of the world, you can therefore get that they will all agree that Monday is a day in a week. So there is no contradiction. And so the given statement is well defined. Okay? Since we are already done with well-defined or not well-defined, let us now proceed with the language of sets. Let us now proceed with this example. A is a set of colors. So if you're going to represent the given statement mathematically, this can be written as A equals colors, wherein the term colors is enclosed by braces. So it only means to say that the term or the word is equivalent to the equal symbol, while a set of is for the given braces. So if you're going to read the second statement, A is a set of colors. So that is how you are going to write a specific phrase mathematically through the use of the different math symbols. Another example is this statement. Blue is an element of the set of colors. So please take note of the phrase is an element of, because there is an equivalent mathematical symbol for that one. So if you're going to write this statement mathematically, it can be represented by this one. Blue is an element of the set of colors. So take note that the phrase is an element of is being represented by this mathematical symbol E. What if you are given this mathematical statement? So as you can see, this can be read as green is an element of set A. The E symbol there is being represented by the phrase is an element of. So what if you are given this statement? Bus is not an element of set A. If you're going to recall what set A is the set of colors. Bus is not a color, so therefore, we can therefore say that this statement is true. So what if you are asked to represent this one mathematically? Therefore, it can be represented by this one with a capital or the symbol E with a slash. So therefore, if you are asked to represent this mathematically, and if you're going to tell that the given object is not an element of a given set, we are going to use this symbol E with a slash. So let us now proceed with this example. P is the set of primary colors. So if you're going to think of the different primary colors, they are the following. So we have the red color, the blue, and the yellow. And since there are only 3 primary colors in the given set, therefore, the cardinality of set P is 3. So please take note that if you're going to recall the term cardinality, this means that it is simply the number of elements in the given set. And if you're asked to write this mathematically, cardinality is represented by small letter n, and beside it is the name of the given set enclosed by parentheses and the number of elements in the given set is written beside the equal symbol. So what if you are given this example? Set D is an empty set or a null set. So if you're going to recall the definition of a null set or an empty set, this is a set having no elements or the cardinality is equal to 0. So if you're going to represent null set or empty set, it can be written as these two symbol or any of the two given symbol. The first one is braces containing no element inside the given symbol, or 0 with a slash. So take note that these two symbols can be used interchangeably. The next lesson that we are going to discuss is the ways of writing a set. And there are 2 ways of writing a specific set. The first one is the rooster notation, and the other one is the set builder notation. The first way of writing a set is the rooster notation. And when we say rooster notation, this is the method of listing down all the elements of the given set, and they are separated by commas and enclosed by braces. Please take note that rooster notation is also known as the listing method. Okay, an example of a set written in rooster notation is this set. So if you're going to read the given set, this is read as P is the set of primary colors. So please take note that blue, red, and yellow are primary colors. And as you can see here, they are separated by commas and enclosed by braces. So therefore, this set is in the form or is in the rooster notation. Another set in rooster notation is set O. As you can see in the given set, the elements of set O are numbers that are separated by commas and enclosed by braces. But if you're going to look closely at the given set, it contains 3 dots before the closed braces. And as you can see here, these symbols or these 3 dots represent the term ellipsis. And when we say ellipsis, this is, or there are, it implies that there are a lot of terms after the given number 9. And so, this can also be read as so on and so forth. So, if you're going to stumble upon this given symbol and there is no last element in a given set, therefore, the given set is an infinite set because there are a lot of numbers after the number 9. Another example of a set in rooster notation is set C. As you can see again, this set consists of numbers as elements and they are separated by commas and enclosed by braces. But take note, it also used the ellipsis symbol to signify that there are still numbers after the number 3. But take note that the last element of the given set is 21. So therefore, the ellipsis here signifies the numbers in between 3 and 21. So therefore, the given set has countable elements, and so set C is an example of finite set. Another way of writing a given set is through the set builder notation. So when we say set builder notation, this is the method of writing a set by describing the elements through a mathematical symbol. And that is, here is an example of a set in set builder notation, and that is set P. Take note that this set builder notation can be read as P is the set of X such that X is a month. As you can see here, the vertical line between the two X's is read as such that. And to look at the specific symbol. So if you're going to look at the second example, set E is in set builder notation because of the vertical line. And as you can see here, set E can be read as E is the set of X such that X is an even number. So let us now proceed with the set builder notation and rooster notation. So we are going to convert a specific set from set builder notation going to rooster notation, and we can easily identify the differences between the two methods of writing a given set. So let's say, for example, you are given set L, and this is read as L is the set of X such that X is a letter in the word book. So therefore, if you're going to convert the given set into rooster notation, this can be expressed as L is equal to BOK. And take note that the letters must be separated by commas and enclosed by braces. So as you can see, the word book contains only 3 letters, but there are two letter O's. Okay, so take note that if you're going to go back to the definition of a set is a well-defined collection of distinct objects. So you're only going to write the specific element only once, because there's only one letter O, even though that it is somewhat repeated in different bases or in different words. You're only going to write that as a single entity or only one letter. Okay, so that is the difference between set builder notation and rooster notation. So how about this example? So once again, you are given a set in set builder notation, and we are going to transform that set into rooster notation. So you're given set M here, and this is read as M is the set of X such that X is a prime number. Please take note that when we say a prime number is a number whose factor is itself and 1. So therefore, if you're going to write the given set in rooster notation, it will be, you're going to list down every single one of the given prime numbers, starting with the number 2, 3, 5, 7, and so on and so forth. So as you can see here, the given set is in rooster notation, and there are a lot of prime numbers after the number 13, and so we use the 3 dots or the ellipses here. And so set M is an example of an infinite set. Again, what if you are given a set in rooster notation and you are asked to convert the given set into the set builder notation? So therefore, what if you are given set K here? And set K contains the numbers 0, 2, 4, 6, 8, 10, and so on and so forth. So as you can see here, the first thing that comes into your mind will be K is the set of X such that X is a number. Okay, so as you can see, 0, 2, 4, 6, 8, and 10 are all numbers. But the given conversion is wrong. Why? That is because 1 is not in the given set, 3 is a number that is not in set K, as well as for numbers 5, 7, 11, and so on and so forth. So therefore, we should be more specific when it comes to expressing a specific set from rooster notation going to set builder notation. So therefore, the right method or the right conversion of the given K is the set of X such that X is an even number, because 0, 2, 4, 6, 8, and 10 are all even numbers. So what if you are given another example of a set in rooster notation and you are asked to convert that into set builder notation? So let's say you are given set H, and set H contains the numbers 6, 7, 8, 9, 10, and 11. So the first thing that will come into your mind will be they are all numbers. So you're going to convert that as H is the set of X such that X is a number. But unfortunately, there is a more specific term, kind of number, for the given elements of set H. And so, this is not the correct conversion of the given set H. And you can specify what kind of number are these elements in set H, and we can therefore conclude that 6, 7, 8 until 11, they are all whole numbers. So therefore, we can therefore say that H is the set of X such that X is a whole number. Yes, that is somewhat correct. Number 6, 7, 8 until 11 are whole numbers. But how about the numbers 12, 13, 14, and the numbers less than 6 such as 5, 4, 3, and 2? They are also still whole numbers. So therefore, we are going to add another phrase from the given statement so that it may suit the given set. And so, the correct conversion of set H from rooster notation to set builder notation is set H, or H is the set of X such that X is a whole number between 5 and 12. So as you can see, there is a restriction between the given set, and that is now how we are going to express a specific set from rooster notation going to set builder notation. Let us now proceed with another kind of topic under set, and that is another kind of set. Okay, we are already done with the different kinds of sets, but this time there are also another batch of sets wherein they are somewhat interrelated with another kind of set. So what if you are given this one? These are the names of a specific class in grade 7. They are the following names. Okay, we have Hill, Joy, Jo, Jay, Red, Gus, and Shy. So as you can see here, if we are going to only consider the given names in a specific grade, therefore, we can say that we are only going to focus our attention to the different names in front of us. So therefore, this kind of set is known as a universal set. And when we say universal set, this is a set under consideration, or we are only talking about this specific elements in a given set. And since that is the case, if you're going to write the universal set into rooster notation, please take note that universal sets are always represented by capital letter U. Okay? And we are going to list down all the given elements in the given universal set by rooster notation, and they are separated by commas and enclosed by braces. So since we are going to focus on the different names of students in grade 7, these 7 names, what if you are going to group them? Okay? So the first group is Hill, Red, Shy, and Gus, while the second group is for Joy and Jay, while the third group is Jo. So based on this one, the given names came from the universal set U, and so we can therefore say or write this one into specific or smaller versions of the universal set. And so the first set will be known as A, the second is B, and the third is C. Therefore, if you're going to write set A in rooster notation, it will be represented by Hill, Red, Shy, and Gus, separated by commas and enclosed by braces, while for set B, it can be written as Joy and Jay, separated by a comma and enclosed by braces. And for the last one, we have the element of Jo, or the name of Jo, for set C. And since that is the case, they are somewhat a smaller part from the universal set U, therefore they are known as proper subsets. So please take note of this one. They are smaller versions that came from the bigger set, which is known as the universal set. So if you're going to list down all the given sets, specifically the universal set and the proper subsets A, B, and C, as you can see here, there is another kind of set where we can show relationship between the universal set and the proper subsets. Okay, so here are the given symbols. So as you can see here, set A with capital letter U that opens to the right, and the symbol for the universal set U. And as you can see here, this is read as is a proper subset of. So therefore, this one can be read as A is a proper subset of U. Why is it that this is written in this form? Because all the elements in set A are also elements of the universal set. Another one is, this can be read as set C is a proper subset of the universal set U. Okay, that is how we are going to interrelate the proper subset and the universal set. But what if we are going to change the places of the universal set and the proper subset? So as you can see here, the universal set U is on the left side while the proper subset is on the right side. So this can be read as proper superset of. So please take note of the difference between the two, okay? So the capital letter U opens to the left. This can be read as proper subset. But if the letter U opens to the left, therefore it is read as proper superset because all the elements in set A are in set U or in the universal set U. This can also be read as universal set U is a proper superset of set C. Okay? Again, when we say universal set, this is simply the set that contains all the elements under consideration. We are only going to consider a specific element with respect to the given problem. And when you stumbled upon this symbol, a capital letter U that opens to the right, this means to say that A is a proper subset of B. Okay. So this only means to say that all the elements in A are in B, but not all elements in B are in A. So that is the difference between the two, okay? So the other way around. As you can see here, it only means to say that this mathematical symbol can be, or it only means to say that C is a proper superset of D. Ibig pong sabihin, not all elements in C are in D, but all elements in D are in set C. So as you can see here, there are a lot, or there is, the cardinality of set C is much more bigger than the cardinality of set D. So, kung saan po naka-open po yung parang letter yung yan, it means to say na mas marami po yung elements niya kesa sa isang set. So, that is for... Okay, so what if you're given this one? You are asked to list down all the given subsets of A. Let's say, for example, the given elements of set A is 1, 2, and 3. And as you can see, the given set is already in rooster notation. So therefore, here are the possible subset. When we say subset, this is somewhat a smaller version of the given set. So therefore, the first one is the subset containing only one element, wherein it can be written as 1, 2, and 3. So these are all the given subsets containing one element from set A. How about the subset containing two elements? Here are the possible subsets. Okay, so they can be the subset 1 and 2, the elements containing 1 and 2. We also have the subset having two elements, specifically it contains the numbers 1 and 3, and the last one is the subset containing two elements having the elements or numbers 2 and 3. Please take note that we can also consider the set itself. Okay, please take note that these 6 are not all the subsets of A. It can also contain 2. It has 2 special subsets. So please take note that we can use a specific formula to determine the number of subsets of a given set, and that is through the use of the formula 2 raised to n, where n is the number of elements. So as you can see here, n is the exponent of the number 2 here, where 2 is the base. Okay, so let's say, for example, here n is signifying the cardinality of, or the number of sets in the given set. So therefore, Based on set A, it only contains 3 elements, so therefore n is equal to 3. So by substitution, this can be written as 2 raised to n, and by it can be equal to 2 raised to the third power. And when we say 2 to the third power, it can be expanded into the expression 2 times 2 times 2. So therefore, we are going to get the product of all the given numbers. Therefore, the answer is equal to 8. Therefore, set A contains 8 subsets. So based on our example, we have already written, or we have already found out the first 6 subset. We are still looking for the other 2. Okay? Okay, so since we have already identified the 6 subsets of set A, therefore, we are still lacking 2 subsets. And please take note that these 2 subsets are somewhat special because it is applicable to all sets. So the first one is the set itself, which is the set containing the numbers 1, 2, and 3. So take note that the set itself, or the set itself is a subset of itself. Okay? The next one po is the null set, or the symbol 2 braces with no numbers in the middle, or 0 with a slash. So please take note of that one. You cannot combine the 2 symbols, but they can be used interchangeably. Okay? So please take note of this one. So let us now go to the next example, and you are asked to list down all the subsets of set B, wherein it contains 2 elements, specifically the letter I and the letter T. And as you can see here, the cardinality of set B is 2. Therefore, n is equal to 2 because it contains 2 elements only. And so, using the formula 2 raised to n, by substitution, that is now 2 raised to the second power, or that is simply equal to 2 times 2. Therefore, the total number of subsets of set B is 4 subsets. So, if you're going to list down all the given subsets of B, the first one is the subset containing only 1 element, and that is set I and T. And the other 2 special subset is the null set and the set itself. So a total of 4 subsets. Okay, so since we are already done determining the 4 subsets of B, what if we are going to relate the given subset to the set itself? So as you can see here, the null set is a proper subset of set B. Okay? The next one po is the subset containing only 1 element, and that is the subset containing I as its element. So therefore, still this can be read as a proper subset of set B. Okay? The next one is still the same, but if you're going to proceed with the set itself, we are going to use a specific symbol which is read as a subset of rather. Okay? So as you can see, the subset itself is the set itself. Okay, they contain the same elements, and if they contain the same element, we are going to use this specific symbol with the capital letter U that opens to the right with an equal symbol, or one equal symbol po that is below the given capital letter U. It signifies subset of, not the proper subset of. That's the difference between the two. Proper subset of contains only no element, or smaller versions, or smaller number of elements not equal to the total number of elements of the given set. Okay, let's now proceed with the next lesson, and that is the Venn diagram. And when we say the Venn diagram, this is simply a visual illustration that uses shapes to show relationship among sets. So therefore, the Venn diagram is used to visualize the given problem when it comes to sets. So here is an example of a Venn diagram. So how are we going to sketch or draw a Venn diagram based on the given problem on a specific number? First things first is you're going to draw a rectangular box. Okay? So here is an example of the first thing that you're going to do is always draw a rectangular box here. And so it only means to say that you're going to use a capital letter U because we are only going to talk about a specific set, and this is the set under the set containing all the elements under consideration. So we are implying about the concept of universal set. Okay? So you make sure that you're going to write capital letter U at the upper corner, left corner of the rectangular box to signify that we are using universal set, the concept of universal set. Okay? So if it involves two or more sets, we can use this two overlapping symbol. We can use a circle to represent the first set. Then we can also use another second circle for the second set. And if they share common elements between set A and set B, or the first and second set, therefore, we are going to write the common elements in the green shaded region of the two circles, while the other elements that are not the same will be for the color yellow and the color blue, while the elements that belong to the universal set but do not belong to the two sets will be outside the two circles but still inside the rectangular box. Okay, so what if you're given this problem? You are asked to represent these sets using the Venn diagram, and you are given the universal set U, wherein this is set U is the set of the first counting numbers, and set A is a subset of the universal set U, wherein it contains the elements 1, 3, 4, 6, 7, and 9, while for set B, it contains the elements 2, 3, 4, 5, 8, and 9. So if you're going to represent this one through by a Venn diagram, it will like this one. Okay, so make sure that you're going to write all the given sets in rooster notation, not in set builder notation, so that you can easily identify the common elements in every set. Okay, so first things first, draw a rectangular box and write the capital letter U at the upper left corner of the given box inside. Okay, inside the given box. Then draw two circles, and then first things first, you're going to identify the common elements between set A and B. And so the common elements between set A and B are the numbers 3, 4, and 9. So therefore, you're going to write the numbers 3, 4, and 9 at the green region. Okay, so 3, 4, and 9 will appear at the green region. And please take note that you're going to write the name of the given set on the upper part of the two circle. Don't forget about that. Okay, so the remaining numbers for set A are the numbers 1, 6, and 7. So therefore, you're going to write these numbers in the yellow region. While for the blue region, you're going to write the remaining numbers 2, 5, and 8. And please take note that we are going to look at the universal set U containing the first you're going to take a look at all the elements of the universal set U if all the given elements are listed inside the rectangular box. And so, there's a missing element, and that is the number 10. So, therefore, you're going to write the number 10 outside of the two circles, but still inside the rectangular box. Okay, what if you're given this problem? Represent these sets using the Venn diagram. So, therefore, you're given the universal set U and the subsets M and N. So, as you can see here, U is the set of letters in the word mathematics. Set M is the letter or the set of letters in the word static, and set N is the set of letters in the word STEM. So please take note that make sure that you're going to convert the given sets into rooster notation so that you can easily identify the elements in the given set. For the universal set U containing the letters in the word mathematics, make sure that we are talking about the distinct letters in the word mathematics. So you're going to write every distinct letter. While for set M, it contains the letters S, T, A, I, and C. And for set N, it contains the letters S, T, E, and M. Identifying or converting the given sets in rooster notation, that's now the time that you're going to represent it using the Venn diagram. Again, draw a rectangular box with a capital letter U at the upper left corner of the given box. Then, you may draw two circles here. So, as you can see here, then the first thing that you're going to identify is the common elements between set M and set N. And as you can see here, both sets contain the letter S and T. Okay? And make sure that you're going to write the name of the given sets at the upper part of the given circle. Okay? So, the remaining letters for set M are the letters A, I, and C, while the remaining letters for set N are E, and M. And as you can see here, have we already listed all the given elements in the universal set U? As you can see, we have already listed only 7. So therefore, there is one remaining letter, and that is letter H. So therefore, you're going to write letter H outside the two circles, but still inside the universal set U here. And please take note that if two sets contain common elements, therefore, they are known as joint sets. So what if you're given another problem and you're asked to represent the given sets in the Venn diagram? So again, make sure that you're going to identify common elements between the two sets X and Y. So if they don't have any common elements, therefore, we are only going to write the given letters in the yellow region and in the blue region. So therefore, it can be represented as this one. And if they don't have any common elements between the two sets, therefore eliminate or draw two separate circles wherein all the given elements are on each circle. So the given figure or circle or oblong must not be overlapping because they don't have any common elements. And since that is the case, if there are sets that have no common elements, we can therefore say that these two sets are known as disjoint sets. So what if you're given another situation, but this time, here is the problem. So you're asked to once again draw the given sets or represent the given set through the use of a Venn diagram. And so, based on the given subsets X and Z, we are going to write the common elements between the two sets at the green region. So therefore, we are going to write C and D at the center part, while the remaining letters for set X will be in the yellow region, which are the letters A and E. And as you can see here, there are no more remaining letters for set Z, but for the universal set U, we are going to be writing three other letters outside the two circles. And so, they are the letters G, B, and F. So, we are going to change the given figure so that it will be suited to the given problem. This is how it must be. So, as you can see here, set Z is inside the big circle X, and there are letters outside the two circles. Okay, so that is how we are going to write this one. And this problem or situation represents subsets of a given set. Okay? And for the last topic that I will discuss to you is the operations on set, which involves the intersection of sets, the union of sets, and the difference of sets. So what if you're given this Venn diagram? So as you can see here, what are the common elements of M, set M, and set N? So as you can see, the answer here are the elements inside the green region, specifically the letters S and T. And so, the common elements of M and N are S and T. And since we are talking about the common elements of the two given sets, this kind of operation, so take note that if you're going to write these two elements in set, in the sense of sets, we are going to write them by, they are enclosed by braces and separated by commas. And so, the common elements of sets M and N refers to the intersection of the two given two sets. Okay? When we say intersection, the symbol for the intersection is an upside down U, and the upside down U is in between the two given sets. So therefore, set M, the intersection of sets M and N is S and T. So that is our answer. So what if you are asked another question? So still the same Venn diagram. So what are the elements when M and N are combined? So you are asked to determine the elements if you are going to combine set M and set N. And so the answer here will be the combined elements of set M and set N are A, I, C, S, T, E, and M. So all the given elements inside the two circles is the answer. Okay? So since that, if you're going to write this one in Rooster method, we are going to separate the given elements by commas and enclose by braces. And so, we are talking about the union of two sets if you are asked to combine the two sets. Okay? So, please take note that the symbol for the union of set is a capital letter U. But kapag upside down U, it refers to the intersection of sets. So therefore, the union of M and N is A, I, C, S, T, E, and M. So what if you are given another question? So what are the elements in M that are not in N? So, ang tanong naman po rito is, ano daw po yung elements na nasa loob ni M na hindi kabilang kay set N? So, therefore, the elements in M that are not in N are the elements A, I, and C. Ito po naman yung mga letters na nasa yellow region. And when we talk about the elements in M that are not in N, talking about the difference of set M and N. So therefore, if you're going to write the answer to the given operation. Therefore, it should be written in Rooster notation. So, the difference of M and N is A, I, and C. So, mathematically speaking, when we say difference, we are talking about the minus sign. And still, it is somewhat related. It can be used in the set, the concept of sets. So, therefore, M minus N is equal to A, I, and C. That is how we are going to write the given set mathematically. In set N that are not in M. So, it's the other way around, okay? So, the elements in N that are not in M R, E, and M. Sila naman po yung mga nasa blue region ng bilog. Okay? So, as you can see here, signifies the difference of sets. But this time, we are going to write this one in Rooster notation, and that is N minus M. It is different from the other one. That is M minus N, but this time, it is N minus M. So, please take note of this one. Sila po yung natira sa unang set pag inalis po natin yung parehas na element sa dalawa. Okay? That is our consideration. You're only going to look at the first set. Okay? Titignan nyo lang po yung nasa unahan na set. Okay? Yan po. So, again, what do we mean by this symbol? It only means to say that it represents the intersection of A and B, and it contains the common elements about this symbol. So, a capital letter U that is upward implies the operation on union of sets. And it means union of A and B, and it contains the combined elements of A and B. The other one, A minus B. So, this is the difference of sets. It means the difference of A and B, and it contains the elements in A that are not in B. Ibig sabihin po, yung mga elements na natira kay A, pagkatapos nyo pong alisin yung magkaparehas na elements sa dalawa, is B minus A. Again, this is a difference of set, but this time, it contains the elements in B that are not in A. Yung mga elements po na natira sa B, pagkatapos nyong alisin yung magkaparehas na elements sa dalawa. So, that is for the operations of. So, what if you are given this problem? So, you are given sets in Rooster notation, and you are asked to get the union, intersection, and difference of sets. So, let's say, for example, you are given this one. What is the intersection of A and C? So, take note, you're going to focus your attention on sets A and C only. Ignore set B. Okay po? Tignan maigi po yung set A at saka yung set C. After that one, look at the common elements of the two sets. And since we are talking about upside down U or intersection, yung magkaparehas lang po na elements ang titignan po natin dito. And these are the numbers 2, 3, and 6. So therefore, the intersection between A and C are the numbers 2, 3, and 6. So make sure that you're going to write your answer in Rooster notation. You are given another problem. What is the intersection of B and C? Again, focus your attention on set B and C. Tignan maigi po si B at saka C. Pabayaan po muna si set A. So, since we are talking about intersection o yung pababa po, therefore, you are going to look for the common elements, yung magkaparehas na elements po sa dalawang set. So, therefore, ang magkaparehas po are the numbers 3, 6, 8, and 9. So, therefore, the intersection between set B and C are the numbers 3, 6, 8, and 9. Next question. What is the union of A and B? So, we are talking about union. capital letter U na papunta po sa taas. So, therefore, U for union. So, take note of that one. So, focus your attention on A and B. So, it means to say, kapag union, you are going to combine the elements of the set. So, paghahaluin nyo po yung dalawang sets. So, it means kukunin nyo po yung, ipaghahalo nyo lang po yung dalawang elements, pero this time, kung may magkapareha, isa lang po ang isusulat nyo. Okay? So, therefore, the union between A and B are the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. You're going to combine. Paghahaluin nyo lang po yung elements ng A at saka next stop. Here's the next problem. What is the union of A and C? So, again, take a look at set A and C. You're going to combined because we are talking about the operation on union. So, it means to say, paghahaluin nyo po yung A at saka C. So, therefore, ang sagot nyo po rito is 1, 2, 3, 4, 5, 6, 8, 9, and 10. Okay? Paghahaluin nyo lang po yung elements ni set A at saka ni set. Next, what is the difference of A and C? So, therefore, if you are asked to get the difference of two sets, ang gagawin nyo lang po dito is A minus C. Unang-una sa lahat, you're going to identify the common elements between the two sets. So, therefore, the elements that are both in A and C are the numbers 2, 3, and 6. So, these are not yet your final answer, okay? Take note, kapag A minus C difference, kukunin nyo lang po yung natirang elements sa naunang set. And since yung naunang letter po is A, dyan po sa A minus C, therefore po, ang kukunin nyo po dyan are the numbers 1, 4, and 5. So, that is A minus C. Okay. How about C minus B? The difference between set C and set B. Again, determine the common elements between set C and B. They are the numbers 3, 6, 8, and 9. So, take note kung ano po yung nauna po sa operation. Si C po ang tinatanong dito, C minus B. So, take a look at set C. Tignan maigi po siya dyan, si set C. Ano yung natirang number? They are the numbers 2 and 10. So, therefore, the answer is 2 and 10. Pabayaan nyo na po yung natira kay set B. Ignore the elements in set B. We are just going to get the numbers or elements in the first set, which is set C po. How about this one? It contains two operations. So, as you can see, it involves intersection and difference. So, first things first, you're going to operate or get the answer for the first operation, which is on the operation inside the parenthesis, which is the intersection. So, therefore, A intersection B, get the common elements between A and B. They are the numbers 1, 3, 4, and 6. So, therefore, the intersection between A and B are the numbers 1, 3, 4, and 6. After that one, we can now, therefore, get the difference between C and this number. Okay? So, ibig pong sabihin yan, we are going to identify the common elements between set C and the set containing the numbers 1, 3, 4, and 6. And so, we all know that set C contains the numbers 2, 3, 6, 8, 9, and 10. Therefore, eliminate the common elements between the two sets. So, therefore, we are going to eliminate 3 and 6. Take note, nauna po si C, therefore, aalisin lang po natin yung number 3 at saka number 6. And so, yung nauna pong letter C, that will be our focus on this problem. So, ang natira na lang po sa set C are the numbers 2, 8, 9, and 10. Because C minus the intersection of A minus B, ang sagot po dyan is 2, 8, 9, and 10. So that ends my discussion for your home-based learning modules for Thursday and Friday. Thank you for listening, and I hope you learned some of the given concepts for sets. See you on the following week. Thank you.